Good evening, good day. Nice to meet you here. It's my duty to tell you that if you somehow messed up, at the track A, at the moment is going Luis Kobuchi, a software engineer who also loves to share his thoughts about quality tests and objects-oriented programming. If you are on the right spot, it's at track B. Today, to address to you is Florian, Director of Software Development at Performance Advertising, and he will tell us where will we be when the storm comes.
Thank you very much for the introduction. So as you can gather, this is not about the weather today, but it's going to be about how you can make your site so it's going to survive a severe storm. The title, where will you be when the storm comes, it's a bit poetic, I must admit, but I think the image is quite right, because you got the site there and it's running everything nicely, and then all of a sudden this traffic storm comes and it just blows everything to pieces and you're offline. And you're offline while there's thousands of people coming to your site and they want to see it, and of course that sucks, you don't want to have that. And the problem with this kind of thing is that it's really hard to learn, because you can try to fix things and make things better, and then you got to wait for the next storm to come and see if the things you did, they work. And the other problem with it also is that the management types, they get a bit nervous about it when they just spent, 50,000 euros on a TV spot and nobody was there, nobody could see the site. So of course you don't get too many tries in getting things right. I was lucky to be working for a number of really large sites in the past, and this talk is about showing you some of the things I learned along the way. One of the sites was About You. They're a number 3 fashion retailer now in Germany. They started as a greenfield from scratch, built everything new, and they became, they're number 3 now. It's a PHP application, and back when I was working for them, they would have about 100,000 visitors per day. I guess today it's even more. And what they also had is they had huge media spendings. They had TV spots, and not just one TV spot, but 3 TV spots happening at the same time. So you would have really immense traffic peaks, and it was really hard to handle them. And the other shop I was doing is called Rebel. It's not quite e-commerce, it's something like eBay, but for fashion clothes, for second-hand fashion clothes. They're also quite large. They get about 60,000 visitors a day, and they're all over Europe, so it's like 5 languages and 18 shipping countries. And also, this is a thing the media really love, so they would get huge press coverage and Twitter and Pinterest and all these social media. So you would have traffic storms out of nowhere because somebody posted something about you, and then all of a sudden you got this storm coming in. I stopped working in e-commerce. I now work for a company that's called Performance Advertising. They have a sister company here in Belgrade, so I'm here quite often. And this is why I'm also really happy to be speaking here at the PHP conference in Belgrade. What PA does is, Performance Advertising does, is they're an agency that does online marketing, online advertising through different channels. And so there it's not so much about the number of users, but there it's about the amount of data and the data you have to process to help to improve those ads. We got a booth down there. Feel free to come around later on. There's going to be beer for a chat if you want. So let's start this. This is a storm. So if you see this on Google Analytics, then normally people tend to get a bit nervous, because as you can see all the diagram there, this happens within a minute. So you go from, 300 users to 8,600 users. So this, for example, here was our first TV spot at Germany's Next Top Model for Rebel. And this was our first try, like a first version of if you could survive that. And it was a bit problematic. You'll see that in a bit. So these figures here, this is what you can see. This is what arrives at our servers. So this is the Ingress load balancer. So this is all pages, all JavaScript, all CSS, but not the images. The images were loaded from a CDN. So you see there were the numbers. Don't be deceived. I improved the quality a little bit. I only had poor quality screenshots. So you see you have about 2,800, 2,700 requests coming in per second. So that's quite a lot, out of which quite a number get eaten by the cache, so only 330 hit the backend. The rest of them, 88%, as you can see, is eaten by the cache, which is a really good thing, because otherwise the traffic would be insane. At the server level, you have something like this. So you see, we didn't get through the storm too well. So we had response times going up to like 20 seconds, so it hit us really hard, that thing. At the bottom right thing you can see, so the number of requests coming to the backend servers, this is about 220 requests per second. That's quite a lot, and it hit Rails really hard. That was the Rails application. it looks pretty bad. Actually, it wasn't so bad after all. The site was still usable because most of the site was coming from the cache. So people could still surf the site and see something. It was just that the endpoints that were loading the basket on the user profile, etc., they were really slow to load. So that hit us quite hard. You can also see something here, the green bar graph. It's the request queuing. So apparently Rails was not able to serve requests fast enough. And why is that? Some basic maths here. So if you want to figure out how much load your site can take, there's two numbers which are important, and it's just rule of thumb, and this also applies to PHP and Python and Ruby as well, which are process-based languages. So the number of hits your site can take is basically the number of CPU cores you can have divided by your average response time. And for this bandwidth, you can also hit bandwidth limits. So your server probably is going to have a gigabit Ethernet connection, and you got to divide that by your average response size, and this is going to give you how much traffic you can send through the wire. In the above example, we had 96 CPU cores for the site to serve, and we had a response time of half a second in the average. So that means we could serve 192 requests max per second. We were at 220. So yeah, this is why the request queuing kicked in. Problem with the request queuing is it's going to make all the other processes slower, and it's a downward spiral. And the more you run into that, the slower all the other processes get, and the more it's away downwards towards your site's offline. Also, one thing, the bandwidth, it's actually quite a limit. People don't think about this too often. So if you think you have a gigabit Ethernet connection, and that can serve at most, and this is unrealistic, 125 megabytes per second, and you get 300 kilobytes response size there, so that's 416 requests per second. Then your server is blocked and you bombed your network connection. So this can also affect you. So as you can see before, you need to handle those traffic peaks. So if in the above example, we didn't have a caching layer in front of that thing, you would have had 2,000 requests per second going to our servers, and you would have required about 1,200 CPU cores to handle that traffic, and yeah, you just can't do that. I mean, it's silly expensive, and even if you got those cores, then you would probably just kill your database because it's just too much traffic that gets there. Weapon of choice in this case, and I can just recommend this piece of software, is Varnish. So Varnish is a low-level HTTP processor. It speaks HTTP. It can understand requests coming in, and it can operate on the parameters and the header fields in HTTP. Varnish can then cache the data you get on disk or in a memory. And what it also has, and which is really powerful, it has a built-in programming language. It's called VCL. So you might ask yourself, why would I need a programming language in a cache? I'm going to give you an example. So for example, geo-redirects. We want that users that come from France get redirected to /fr website. And of course, you got to do this in Varnish because you're hitting the cache, and it might be that this request never hits your backend, and so you have to handle this kind of logic in the front end. And there's way more logic there, so you're going to have logic in the front end. This VCL language gets compiled directly into native C object, and then it's really, really fast to work on. So you're going to see some figures, it's silly fast, really. Another use case which is really cool is you can hook Varnish up to Redis. So you can do, request comes in, speak to Redis, and do something with the data it gets out of Redis. So this is really nice. And so let's have a look how fast Varnish actually is. So above diagram, this is now about you. This is the large category page. This is women's clothes. And you see uncached version, 600 milliseconds, something like that. Not brilliant, but okay so far. And then at the bottom, you get the cached pages, and you see you're something between 10 milliseconds, 8, 7 milliseconds. So it really, really is silly fast. So it just doesn't bother about the traffic at all. And now this is Varnish at 6,000 concurrent users. So it's being hit really, really hard. And you see it's not doing anything. Really, it doesn't bother. Varnish can saturate gigabit Ethernet, no worries. I mean, it's silly fast, and it's a really cool piece of software. Then, of course, the challenge is you can't just say, oh, let's cache everything and we're good to go. Of course, that doesn't work like that. It requires you to have the site completely stateless. Stateless as in you cannot have the username on the site. You cannot have the user's basket on the site. You cannot have, I don't know, anything which is individual to user. That must be kept out of the things you want to cache in Varnish. So in order to do that, best line of action would be you move that data into APIs, and then you render the site stateless. JavaScript kicks in, goes to these APIs, pulls the data, renders it on top of the HTML, and you're good to go. So that's the solution. downside of this, of course, is your JavaScript becomes much more complex. So you're sort of leaving the world of where you're rendering data in PHP, but you're just rendering some basic stuff in PHP, and then a lot of things go on top with JavaScript. Also, one thing you got to realize that your logic in Varnish will be a lot. It sounds like, oh, it's a silly thing, and what should it do? But you're going to have special cases, special handling, special cache invalidations, for example, that if that happens, you want to be sure that this cache gets invalidated, etc. All of this you can do in VCL, and it's quite powerful. Although not the nicest language, it's quite flexible and powerful. An advanced use case, which I really like, this is something really cool, is you can do an API gateway with Varnish. So in this case here now, you got the Varnish cache, and it's hooked up to Redis, and you split your APIs into two types of endpoints. One is stateless endpoints, so a product. It's no individual data there, it's just product data. So when that request comes in, Varnish strips the cookies, gives the request to the backend. So like this, your backend cannot have any state because there's no more cookies, there's nothing that would identify a user to those APIs, so people cannot cheat. You can't have any hidden logic there. And if you got some endpoints which are stateful, like the basket, the customer's endpoint, the wish list, etc., how this can be handled is that when this request comes in, Varnish goes to Redis, gets the cookie from the request, checks the session in Redis and sees, oh, this is user 572. I'm going to strip the cookie still, but add this user ID on the request. So basically, you move your session handling to Varnish, and then again, your endpoints become really silly because they don't need to share any session state. It's just they take the request, they put the ID you give them, they use that, and then they do their logic. So it's quite cool, and this allows you to have your APIs to be cut down as much smaller pieces because you need no shared storage between them. They're stateless, basically. Of course, this is a bit of an advanced use case, but it's quite powerful, and it also helps you to slim down your application, to make everything smaller and move that logic away to the front. Now, the next thing you're going to come across, of course, if you want to scale your site to a lot of users, it's the database. I mean, I know with PHP, everybody's using Laravel and Symfony and all those frameworks, and you get the ORM mapper and the MVC and Active Record, and it's very easy to set up a system, and you can get running pretty quickly with that. So in the case of e-commerce, what you would do, I'd say you'd have something like this. You have a table called products, and on the other hand, you have a table called attribute groups. That would be colors, sizes, material, what you could think of in e-commerce, and then these attribute groups would have attributes like red, green, blue, yellow, whatever, and then you have a many-to-many join table in there where you join these two together, right? Fair enough, makes sense. So if I wanted to query now, that gives me all red or blue products and also products which are size XS. That would look like something like this, right? You join the products, you join the attributes, you join the groups, and then do your query where you filter down on what you want to see. Looking good? So what does Mr. Trump think about this? It's not true, unfortunately. No, it's a bit more complicated than that, unfortunately. So in order to get this right, I mean, just think about why this is not correct. It's basically when you're doing this join, you're joining line by line. So every attribute is a new line. Every product, new line, attribute, new line, product, attribute. And you want to have a combination of it. They have this AND clause in there. So you must have these two attributes on the same line. So what you need to do is you need to have two joins. You join by group, you join by color, and you join by size. Don't bother reading the query, it will make your eyes bleed. But point being is it's 6 queries, 6 joins already now. So then we only have 2 attributes. So you're going to have at least 20 to 30 attributes in e-commerce. So you're going to have tons of joins over and over again. And this will be very hard on the database. And then it gets worse, because what you also need is you need group bys, because these e-commerce sites have the fancy feature of saying, in your result set, you have 55 green products and 21 blue products. So you need to group by again on the attribute groups, and that's the same query again with a group clause. And this you got to do 20 to 30 times again now too. So you're talking about hundreds of joins and here just to get one bloody page rendered, and it's just going to kill you. It's not going to work at a large scale. Also, you can't cache this too good because the query is quite dynamic. I mean, it depends so much on what the user selected, so it's not that the query would be the same all the time. It's quite tricky, so you can't really cache this. So obviously, there's got to be a better way to do this. At About You, we used a piece of software which is called SphinxSearch. Yeah, don't be put off by the website. They haven't discovered CSS yet, but they're really good. Trust me, that's a good piece of software. And it's very fast, it's very lightweight, it's written in C++. And the big advantage of that thing really is that you can query it with a MySQL interface. So you can just take the MySQL client, speak to that thing, and it behaves like a MySQL database. But in fact, it's actually a search engine which has indexes and stores your data for you in there. About that website again, this thing here, also a website by the way, it's hard to see. They run about 60% of the websites on the internet, but still haven't bothered doing CSS styling to their links. But, well, okay, it's a good piece of software. Okay, back again to Sphinx. How a product in Sphinx would look like now is you get a product with the ID, you can add text to that thing, integer values like a price, and then obviously what this thing does here is you're going to flatten down your joins. So you don't join half the database through that thing, but you can do array sort of structures where you can say, okay, this product is in these categories, and this product is available in XS, S, and XL, and is in red. So you flatten down everything into one index, and this of course is going to make things much easier. A query to Sphinx looks like this. Easy, right? This is really cool. Very powerful, super fast. Also one thing you can see here, this doesn't give me the actual product data, it just gives me the IDs of the products. We'll get to that thing in a minute. Let's get a bit more fancy. Yes, I want to get the fancy products, right? So what this does now, it's full text search. Of course, SphinxSearch is a search engine, so you can do full text search. Give me that word which is next to that word. Give me that word, there's 3 next to that word, so you can do everything a search engine can do on the string fields and still do the grouping on the attributes. And if you want to get really crazy, Sphinx can even do those joins I was those group bys I was talking about out of the box. So here, same thing, and the technical term in e-commerce is facets. So you have attributes and they represent facets of your product. So what these facets color and facet sizes gives you is this thing at the bottom. They do a group by on the colors and they do a group by on the sizes. And Sphinx does all of this in one query. So that's pretty cool. I mean, because normally if you do this in MySQL, as we said, it's, I don't know, hundreds of queries just to get there. Yeah, so this is powerful stuff. It's really easy to use, and everybody can just bang together a query like this. So it's quite straightforward. So how fast is Sphinx? Thanks for asking. Very good. So check this out. This is at 3,600 users. We are at CPU load of about 1, so we could have easily handled, I don't know, factor 5 or so. So it's going to be hard taking down Sphinx. So it's quite, as I said, it's lightweight, it's fast. It does exactly one thing, and it does this really well. So it's a good piece of software. Now, as we had it before, I got the product IDs. Now, what do I do with that? Here comes another piece of software, which I think is really brilliant. It's Redis. So Redis, probably everybody knows it here. It's a key value store. The key in our case now would be a product ID, and the value would be the full product data. The good thing now about this is that Redis doesn't actually need to understand the data. You can just say, store this for me, and pull it from there. And this allows you to store the data in a binary format. There's serializers for PHP, IG binary, and message pack. And they take PHP objects and they serialize them really, really efficient, much more efficient than JSON serialize, for example. And just take that, store it onto Redis, and then you save it there and you can look it up. Another cool feature of Redis is the replication. So what you can do is you say, okay, write this to a master, and then it gets replicated to all the read slaves, and you do the reads from the read slaves, and you write to the master, because effectively, you're not going to have too many writes. I mean, the product data, it doesn't change so often. I mean, okay, the quantity might change, the product might get off stock, etc. But it's not that you're bombing it with write queries. It's reads mostly. And if you put everything into pieces here, your architecture might look like something like this. So you still got your MySQL query. You can still do the normalization and the joins, etc. You're a happy camper. You got everything in MySQL, and you can run business analysis, whatever, on that. But for production usage, you use an indexer. That indexer pulls the data, does those monster queries, but it does it once, writes the data into Redis, writes the search data into Sphinx, and then you got your pool nodes, and the pool nodes, they receive a read slave of Redis. So the good thing now is a request comes into one of those pool nodes, and the node does a query to Sphinx. Hey, get me those products ID for, I don't know, the green shirts on that page. Gets back a list of IDs, and then it looks them up locally from the local Redis. So there's a couple of really cool things about this now. So first of all, you don't have any network overhead. I mean, you have some binary data for the SQL query that goes over the wire, but that's just nothing really. It's just a couple of IDs being sent back and forth. And the bulk of the data, the product data, which for About You was something like 300, 400 kilobytes per category page that's being sent around, JSON data. So a lot that stays on that local machine, and there's no overhead there. So this is really cool. Another thing is nice about this is the scaling, because what you do is say, oh, I got this TV spot coming up, then you're going to call Scotty, and after some complaining, he's going to give you a new machine. And all you need to do is to wait for Redis to be in sync on that machine, and then you put it in the load balancer and ready to serve. And same thing, if you want to scale down, take it out of the load balancer, shut it down, easy to go. So this is really nicely scaling, and you can scale up and down without any problems. As I said, another thing about Sphinx, the query language is really nice, and of course gives you the flexibility of a full text search engine. Alternatives to this one here would be, so at Rebel, for example, we used Algolia. They're a search engine as a service. It's a really cool service. They're quite powerful. They're very fast. So how these systems work, also Elasticsearch, is you take JSON objects, you store it at the database, and then you can index this data in the database and you can query it. So it's a similar concept. It's just that it's one system, so you don't have a search engine and a data storage, but it's one thing. Cool feature about these is also they have boosting, so where you can say, I want to take my list of products, but I want to boost certain products so they get washed to the top of the list. That's something Sphinx couldn't do back then. That's quite useful for e-commerce. But there's also some downsides of it. For example, PHP and JSON. It works, but it's slow. It's really slow. I mean, if you take a look at New Relic graphs, you can see that some applications might be eating up like a third of their time just deserializing JSON. It's not really efficient doing that. And also one thing you got to consider is that now you're sending data with the network twice. You're going to the service, pulling it to your PHP process, processing it, generating HTML out of it, and then it gets sent to the user. So data's transferred twice, and this might really bomb your network a lot. So there's a lot of overhead involved here. Also, one thing that's terrible about these two databases is the query format. So especially with Elasticsearch, you got, I don't know, super deep nested JSON objects with 30 levels deep, so you just cannot write a query. It's really hard to write it manually. You can generate the query programmatically quite nicely, but doing it by hand is just terrible. It's no fun. And of course, it's expensive. Algolia costs, I think, at least €1,000 a month for the paid service, so you spend a lot of money there. I think these two frameworks, they really shine if you got a single page app. So if you got everything in JavaScript and you have your JavaScript speak to those engines straight away, then it's probably a good thing to do. But if you want to have PHP rendering, you might also want to consider some of the other systems like SphinxSearch you're doing here. Okay, and then to the last part of the presentation here. There's a couple of things you can do to make your code scale better. It's very general, and of course, your use case might vary. I mean, it's very individual what you got here. So put in this slide. I'm not sure if it might work for you or not, but these are the things that work for us, and I'm still propagating them because I think that it's actually good practice there. So one thing I'm having a constant battle against is active record. Active record is all fun and play until everything explodes. So it's more like a prototyping tool, I see it. Because it allows you to build sites really quickly. It's like, oh, just get a database, put some data in, put active record on top of it, and then it's more tables and more tables and more logic and more business coming in. And then you're going to find yourself that basically everything is connected to everything. All your models are connected through each other, and this will be used in your code. So you're going to have some code in your front end which joins half the database just to get to that one field it wants to get now. And it gets really nasty if you want to refactor this. If you say, oh, I want to take this particular model and pull it out and replace it with something different, because then you're going to find, oh, shit, this is tied to everything in my whole application. It's going to be really messy getting this out of it. Another thing active record is really terrible at is you're going to find things where developers are going to access the database in views. Not just in the main view, but in some very deep nested partial view. They're going to find out, oh, I need this field now, and they do queries in there. And if they're especially clever, they do it in a loop. So you have per product, one query that bombs the hell out of your database, and it brings you down really quickly. So it's as I said, it's a nice prototyping tool, but in the long run, if you go bigger, then this will bite you a lot. So one thing we did to solve this was pretty much an idea by the objective programming gods Fowler. It's called domain-driven design. We had an adaptation, variation of it. I'm not really sure if you got it right, but I think it's something along those lines. It's basically you're trying to prevent direct access to the database, but you're saying, okay, I got a repository, and that the repository is in charge of loading data for me. There's a couple of rules for these repositories. So first of all, these repositories may only return one type of entity. So not 15 entities, one. And another rule is they may return this one entity, an array of this entity, a Boolean, or they can throw an exception. That's it. As you can see in this example now, is the repositories might do joins to a small degree. So for example, here we got the products and we want to have the prices on the product. So the product repository might join the prices and return them there. So that would be basically the realm of the repository to do that. But generally, they shouldn't do that too much. Same thing with the category there. So there's an image which is attached to the category, and you see, okay, my category entity should have the image in it, so you might do the join there with the repository. The repository takes that data, it gets from the database, stuffs it into an entity, it like creates an entity out of it, and gives it back. Second rule here, so these entities, they should be dumb. They should not have access to the database, they should have no business logic, anything in them. So they should basically be data containers, and they should have serialization logic perhaps, deserialization logic, that's fine, but they should be pretty stupid objects. Now, what would you do if you wanted to get a product now? So, for example, take this. You slap a model on top of it. I know it might be a bit confusing here, so this model you got here, it's not the active record model. We also call that the product service at points, but that's just a convention. So this is not the active record model. And this model is the holder, this is the keeper of your business logic. So that thing knows how to assemble a product properly. And how this would work in theory is basically you say, hey, go to the product repo, get me a product by ID. And then the model knows, oh, I must attach a category here. And then it would go to the category repo and say, give me the categories for that product. Then it's going to merge that data and return me a composite entity. So this is going to give me back the business object that I want to use from a controller. And this thing I can take, put it into a view, can work with it. So that's really, that's then really this dump data object I can stuff down into views or into JSON rendering or whatever. So now why is this so cool? There's one feature this allows you to do. It's you can swap your storage backends very, very easily. So now, for example, oh, we're not getting the products from the database anymore. We've put them into an API, or we've put them into Redis, or we've put them into, you name it, some other database. Basically, all you need to do now is you're going to create a new repository. So you have this, I don't know, API product repository here now, and it knows how to get the products from the API. But it doesn't know anything more else. It gets this product. And as long as the product entity stays the same, the rest of the code remains untouched. You don't have to change anything. So this allows you to swap backends really easy. And this is something that's going to really save your ass when traffic starts to increase, because you're going to see that there's bottlenecks. There's this thing which just takes too long to load, and this is this one query that's just killing our site. It's very easy to use that, and you could also add a caching layer here if you got this one thing which is attacked a lot and it gets loaded a lot. So this would help a lot. So in the end, this is not so much about scaling itself, but it's about keeping your code separated and not munching everything together and then having a really hard time of pulling it apart when you need to. So this is going to make your life much easier if you stick to that pattern. As a side note, perhaps, you might even still use Active Record here. So if you say you have an Active Record product repository, perfectly fine, use it. So in the repository, use the Active Record models, load the data, but then when you pass it back, then strip the access to the database. There's a couple of ways you can do this. Basically, most of the frameworks work in a way that you get a static accessor for the model, and if you destroy that one when you give back the model, then Active Record is out of touch. So the database is off limits for anything else that comes behind the repository. So that's a quite nice thing to do. Another thing I've learned along this way is Matroshka caching, or it's sometimes also called partial caching. It's in every framework I've used so far. There's Rails, Yi, Laravel, Symfony, you name it. And what they say it does is basically, oh, you have this thing which is loaded a lot, just cache that partial, take like a view partial, for example, put it on a cache and load it again. And people really love using that because it's really easy to do, and it's just one line of code, cache this, and off you go. The problem you're going to have with this is that you lose complete control over cache invalidations, because now you have nested caches. There's one cache, which is depending on the other cache, which is depending on the other cache. And this is hell, really, because what's going to happen, for example, is that the cache in the middle expires or gets purged because of pressure on the database or whatever. And then you're in a really unpredictable state because you have this one data here and this other data at the end, but in the middle there's fresh data coming in and it doesn't fit together. So it's something you should really try to avoid because it can bite you and it's a pain to debug. So if you want to use caching, I'd suggest either caching at the front-end level, so Varnish, what we're talking about, or if you need to, at the database level, so at the very entry level. But you shouldn't do it in between because it's going to be a mess to maintain, really. And as a last thing, and it's probably going to be a bit controversial, but that's what I've learned in the past, is PHP server-side rendering generally, I think, is a bad idea. PHP is quite fast. If you use Ruby on Rails, for example, it's silly slow, so you might have 50% of your application time spent on HTML generation. Going to that partial, get the data, render it, get the next partial, render it. So you spend a lot of time generating that stuff. And another thing you get there is basically you're going to have two templates because, of course, people will expect a nice front end. So you can't just say, oh, it's all server-side rendering and I don't care. I mean, people are used to snappy modern interfaces these days with drag and drop and right-click and interaction. And when I click here, I want 75 other things to happen simultaneously on the side. So you need to have that. And if you do the PHP side rendering, you're going to have a very hard time keeping your front-end state in sync with what the back-end actually is seeing. So basically, the back-end throws it at the front-end, and the front-end might really, really change underneath from PHP, and PHP it really has no way of knowing how to keep these two in sync. So it's quite nasty to do this. And another thing, of course, in terms of scaling, which this is really nice, is you can really save a lot of bandwidth. And basically, if you use front-end rendering, you have a highly distributed system where you steal your users' computers to render HTML. Because you give them JavaScript, you give them the data, and then you render it yourself, do it yourself. And this, of course, saves a lot of CPU cycles, and of course, also this allows for some really fancy front ends without the pain of having to struggle with PHP. Personally, one thing I really am waging a war against also is jQuery. I know it's been used widely and people love it, but personally I really think it has spoiled a whole generation of front-end programmers because it just allows for some very, very nasty things to do. Like, I don't know, how do you control state and how do you manage that this one component is in sync with this other component? So yeah, you can really, really burn a lot of people there and create very, very messy code with it. So yeah, I'd advise against it if you want to build anything new. So if you were to ask me if I want to build a new PHP application which scales well and which is nicely controllable and which I know will still be there in a couple of years' time given the code and given the architecture, I'd advise on using a micro framework, so something like Lumen, Slim, Silex, which is small, it does one thing and it does it well, as opposed to, I don't know, these monster frameworks which do everything at one place and which become larger and larger and are quite hard to maintain. Split your APIs up into two groups, stateful and stateless APIs. Cache the hell out of the stateless ones because there you can really do it. And then on top of that, you can add a state-of-the-art front-end framework. So Vue is quite nice, Angular is good. I also dig React. It's quite powerful and it allows you to build nice and snappy front ends. And it's also at the advantage of having reusable components. Especially React really shines there because normally front-end code is write and throw away, and next component you build, you're going to write the same code again because there's no way of preserving data or preserving some things within front-end applications. React can do that, so I'd advise on that one. And of course, what this also allows you to do is universal apps. So you might say now, yeah, okay, front-end rendering, this is really nice, but of course, we need the site to be indexable by search engines. So we must generate HTML output and give that to the user. These frameworks, all of them, they allow server-side rendering. So how that would look like is basically you'd have a Node.js server. It runs 99.9% of the code your browser would run. It's just some small differences. So when a user comes to your site, the first request goes to that Node.js server. The Node.js server runs your JavaScript code. It does some API calls to generate that page. It's not going to do the stateful calls, of course. That's going to be left to the browser. Generates the HTML, spits it out to the browser, and then the browser loads it, loads the JavaScript, and basically picks up where the server has left off, and then after that it's just AJAX calls back to the API. So this is a really powerful technology. I mean, it's bit more complicated to develop, but it allows you full control of how the want page to look like from a server-side perspective and what you want to do in the front end. As I said, also this is not so much with scaling, but this is basically a lot on how to manage code and to keep your code flexible enough to react quickly. Because you got to be aware of one thing with scaling also means is you have to react fast. And if you see, okay, my site was just blown away by that traffic peak, and the next one is coming 3 days, well, you got some work to do. And most of these things we're talking about now, basically they allow for quickly swapping things. So you can replace that one component with another one. So that really allows for flexible and composable code. And this is really one day going to save you if you got to refactor everything and do it quickly within 3 days. So that's a good thing you want to do here. All right, that's it so far. Thank you very much for your attention.
Thank you, Florian. It's time for quick questions and answers. If anybody of you wants to ask something, Florian, now it's the good time. Please raise your hand. Thank you. Questions? Da li ima pitanja? Ima? Moment jedan. Evo, izvolite. Molit ću vas samo da to izgovorite u mikrofon.
Hi. Have you tried Nginx for some of the caching instead of Varnish? And when you tried
yes,
it,
yeah.
why did you stick with Varnish?
Because Nginx has limited capabilities with this VCL. So Nginx, you can say cache this, and you can say, okay, the cache keys would be the URL and the cookie, for example, but you have no way of programmatically deciding what you want to do with a request. So as I said, you do geolookup, and you see, oh, this request comes in from France. Now I must take the URL, prefix it with FR, and then send the user there. This is going to be harder with Varnish, and there might be even more complex logic. So this VCL thingy allows you really to move a lot of back-end logic that you had there to the front end and have it live there. So, yeah. Yes,
okay, another question. One moment, please.
Yeah, thanks for excellent talk. My question is, you mentioned like you can have multiple instances of Varnish, right? And would you share that cache between instances, have some shared volume, or every instance should have its own state and its own cache?
I don't think you can share the storage. I mean, there's disk storage, but I don't think you can use it concurrently, really. So yeah, if you really have a lot of, I mean, as I said, Varnish is silly fast. I mean, it can take a lot of traffic, but if you really think you must have multiple instances, then you might have to live with having 2 cached versions of the page happening. So
yeah, that's also completely fine. I was just interested in what's the best practice regarding that.
Yeah, no, I don't think you can do that, unfortunately.
Okay, thanks.
Anybody else? Da li još neko ima pitanje za Florijana? Onda ćemo se zahvaliti. Thank you, Florian.
Thank you very much. Yeah, so if you got more questions, you're going to meet me at the Performance Technology booth. Feel free to come around.
Now I'm going to remind you that in track A, at 12 o'clock, Mirko Svrtan will be talking, a veteran of PHP affairs, BDD practitioner, DevOps enthusiast. Does testing make sense? He will tell you then at exactly 12 o'clock, don't be late. As much as track B, Mark Baker is coming, and we have some questions for him here in about 10 minutes. For those of you who decided to wait here with me, I'm going to remind you that we have evaluation pool, and please take some time to give us your feedback. It would be very important for us. The pool is available through the application you have installed, or you can find it in social media under hashtag phpsrb, odnosno phpsrb. As far as GitHub and the JetBrains are concerned, by filling in the pool, you will be able to get GitHub and JetBrains licenses. We all know you like them, so show them a little support by tagging the account on Twitter. Guarana. This year, our refreshment sponsor is Guarana. They have very interesting activation for all of you. Follow hashtag phpsrb in order to find out how you can win very cool presents. You will be required to answer some questions and send them to Twitter or Facebook by tagging Guarana with added hashtags, hashtag just code no sleep and hashtag phpsrb. The faster you answer, the bigger the chances you get to win the prize. Okay. Now we take some, well, I'll say rather unofficial break. Some 5 minutes until Mark Baker comes here. Thank you.